Hi, watsonx.data is a core component of IBM's watsonx platform, and watsonx is an enterprise-ready AI and data platform which is designed to multiply the impact of artificial intelligence across your enterprise business processes. And the watsonx platform comprises of three components: watsonx.ai, which is an AI studio for foundation models, generative AI, and traditional machine learning. And watsonx.data is a fit-for-purpose data store that provides a flexibility of a data lake with the performance of a data warehouse. So essentially, it's used to scale all your workloads for AI and data anywhere. And what's an X.governance is a toolkit that enables responsible, transparent, and trusted AI workflows for your business. In this hands-on lab and demo, I will introduce you to some of the core components, the features and capabilities of what's an X.data, and we will be showing the web-based user interface, which includes how you handle the infrastructure management, data management, the query engine interfaces, the query command line interfaces, and also how you ingest data into this platform. We will also showcase how you can create schemas and tables easily, and how you can run effective queries that can combine data from multiple data sources. So without further ado, let me just log in onto the platform. Now that I logged in, I have introductory panels, welcome information, as well as a summary of the infrastructure components, including the engines, the catalogs, the buckets, all the databases that have been currently registered with the watsonx.data platform. The recent tables that have been explored since we have just begun with the demo, it's currently showing as 0. The recent ingestion jobs, also, in the future, you will have saved worksheets and the recent queries that you have run to access the information. And on the left hand side, in fact, if you hover over the icons, you have the home icon and the infrastructure manager, which is used to define and associate the infrastructure components. The data manager, which is used to browse the schemas and tables by engines, and you have your query workspace that is used to build and run the queries to that against the data that is currently stored in the environment, as well as a history for all the queries that you passed across the multiple engines, which is in this case Presto or Spark. And also you have the option to manage and access the infrastructure components of data, right? And let me just click the hamburger icon, and yes, I do in fact see these different information. Let me go to the infrastructure manager. The page, in fact, opens with a graphical canvas of the different infrastructure components currently defined in this environment. So you have the blue layer. In the blue layer, you have the engines, the catalogs that are associated. You have it as the purple layer, as well as the buckets. In this case, are correspondingly with pink or red layer. And in fact, each bucket is associated with a catalog. And when you add a specific bucket, a catalog is created simultaneously based on the input from the user. And however, if you add a database connection, a catalog is created for the database connection as well. And both of these will be shown later in the lab. And we can associate each catalog with one or more engines. For this use case, we have associated with Presto. And the topology presented here is rather simple, but imagine a scenario wherein the number of infrastructure components, the number of engines, catalogs is exponentially high. So if I could have your attention to this control widget, so this gives you a handy way to zoom in and out, auto arrange the components or fit the topology diagram to the screen, right? If I want to zoom in, yes, I can do that. Zoom out to have a larger eagle view, and each of these icons we can customize and ensure that the view is more specific to us. Additionally, you can drag and drop the different infrastructure layers across the canvas, right? And not just that, you can pan across the canvas as a whole just by clicking across the black spaces and holding the mouse button down and moving it to drag across the canvas. In addition to the graphical topology view, the infrastructure components that we saw can also be listed in the form of tables, right? And I see we have one engines, three catalogs, three buckets, and zero databases. So the tabs exists for each of these components. We can explore each of these tabs tables independently to see what kind of information we can figure out. And let me just switch back to the topology view. Let me just zoom out and enable fit to screen. Yeah. Yes. You can also view the details associated with each component. For this instance, I'm clicking the Presto 1 engine tile, and details about this include the software version, the number of coordinator nodes, the number of worker nodes, the host name are all shown. Some of these details are in fact editable just by clicking the edit button. You can edit it. However, this is an instance of a developer edition, and we can't do anything more than just change the name and description of the Presto engine. Let me just do the same by clicking on the catalogs. Yes, I do see these informations. Let me click on the iceberg bucket, details, objects, access control. Now let me just hover my mouse over this particular catalog. So once the catalog is highlighted, you see two icons that are available. In this case, there are two icons to manage associations as well as delete. So these depend on the operations that the user can currently perform. But since this Hive data catalog is currently given as default, it's a system managed catalog and we are not allowed to remove it. And that's the reason why you see the delete option grayed out. This is just a representative topology, but as it gets more and more complex, reflecting the enterprise state today, it may be difficult to find the components of interest. And this console makes it easier to find information. And this filter option can be used to find the different components. Let's say I want to find out the running engines that are present. And you can click on the subsequent engines, the types of infrastructure components, and you can use it to find information in a rather quick manner. So the ability to add component is built within, but we can add buckets or databases. However, we will later go through this particular functionality as we proceed through the lab. So the data manager page can be used to explore and curate our data. And in this section, we will explore the page and how we can create our own schema and tables. So the top level navigation point is the query engine, and we can start by selecting this particular engine. But since there is only one engine in this environment, it is selected by default. But in a real production level environment, let's say you want to run it with Spark or any other query engine, you do have that capability. Now that we have the engine selected, we have access to view the catalogs that has been associated for this particular environment. I have two catalogs, that is the Hive data and Iceberg data. So let me just expand these catalogs. And yes, I see that the Iceberg catalog is currently empty, but the Hive data catalog does have predefined schemas and tables. But these data sets are specific to the environment and are not included when you actually install this. And these data sets currently, these are sales data for a fictional great outdoors company, an airline reporting on-time performance data set, as well as a subset of the Chicago taxi public data set. But these are not naturally inbuilt. You'd have to create schemas and tables and associate with the catalogs which you have on the platform. So additionally, the query engine Presto itself includes the TPCH dataset, and this is a decision support benchmark. And this is intended to mimic a real world business workload involving a number of ad hoc queries. So let me just expand the TPCH dataset. Let me also expand the tiny dataset and select the customer schema and table. Now let me just click on data sample to see the sample of the data in the table that we have named customer in this case. Yes, yes. As you can see, I have the information for the table, the associated catalogs and schema here. And there are in fact a couple of ways that you can create schemas, either through running a query on SQL, create schema, create table SQL, or use a third-party database management tool for in this case, but I am creating a schema through the SQL query engine itself. Okay, let me just create the schema. Iceberg, schema. Now let's go and see. Yes, as you can see, my schema has been created under the Iceberg catalog. Now I'm going to create a table and associate with this schema. And for this particular table, I have a sample called my cards downloaded on my system. Yes. Yes, I do see a sample. Next, target iceberg.data, my schema, cars. Yeah. Table format, Apache, data format, Parquet. Yes. Engine details. file name, summary and DDL preview, create. The table is being created. So my new table has been created and it will be viewed under cars. Let me click on this particular table. So you can explore the different tabs, the schema, the timetable, which I will cover later during the lab, the sample of the data, the DDL summary. And additionally, databases and query engines such as Presto has a lot of ways that users can interact with the data. For example, there is usually an interactive CLI that lets users run SQL statements. But the wonderful thing about watsonx.data is that it includes a SQL interface for building and running your SQL statements. This is in fact called the query workspace. And as users and DB architects, we can write or copy our own SQL statements, or we can use inbuilt templates. And in addition to one-time execution of SQL statements, the SQL statement that needs to be run repeatedly, again and again, can be saved as form as a worksheet and can be run as often as needed. And just like the data manager page or pane that we saw earlier, the top of the navigation pane directs us to select an engine to use. And it is this engine that we will use to run the SQL statements. And Presto, as you know, powers the Ubers of the world. And currently, this is the only engine that is used in this environment. However, at production, you can use multiple engines that fit your workloads. Now let me just run a query, and you have to note that a query is identified by a three-part name, which includes the catalog, the schema, and the table name. And let me just run it on the Presto engine. You see the runtime, and as you see, the query result is in fact populated at the bottom of the panel. And one thing that clearly stands out is something called explain. When we are developing or tuning a particular query, we want to understand all of the underlying work that is involved in running it. And this is called as a queries execution plan. And Presto involves this particular explain facility that shows us how Presto actually breaks up the and distributes tasks needed to run a query. In fact, here you see a graphical canvas of the execution plan, which is highly visual. And watsonx.data uses an explain SQL statement on a given query to create the corresponding graph. Now let me just save this worksheet. Okay, m cars mpg1. Yeah, save. Yeah, and as you can see, the worksheet has been saved, and this can be opened and run in the future as needed by simply clicking on it, and this will open a new SQL tab with the name of the worksheet. And any worksheet can be deleted at any time by clicking the delete icon as well. You can subsequently create new worksheets, delete the worksheets that you're working on. In addition to writing queries from scratch or copy pasting from elsewhere, the query workspace interface can also assist in generating SQL for tables that are present in the platform. So let's see what options are available. Generate path. Yes, and the only template for catalogs and schemas is generate path. And you can notice how the name of the catalog was entered in the worksheet. And this can also be done for schemas, and the schemas, the text that gets entered in the worksheet is in the form of catalog and schema. Let me clear this and do the same for cars. And selecting generate path generates a table name, like we saw earlier as a three-part name, catalog, schema, and table. But the other three options that I see are select, alter, and drop the SQL statement. Let me select, generate, select, and a basic select statement querying from the cars table that we uploaded is now entered into the worksheet. And this default statement actually returns 10 rows, of the table, including all the columns. Let me just run it on Presto. So like we saw earlier, the result of this particular query is shown at the bottom of the screen. And subsequently, we can use the explain option to understand how query distributed the tasks. I can also zoom out, zoom in, and download this particular explain graphic. Yes. So now moving over to the query history page. So the query history page lets us audit all the currently running queries and the queries that ran in the past. And this include queries that users have run as well as used for internal management, right? And you have the filter option. Okay, let me just refresh it. Yes. So As I said, the query history page opens with a list of queries that are currently running, and included at the top is a search bar for us to search specific queries of interest. And this can also be filtered according to failed, finished, and the particular engine that ran that query. In this case, we only have Presto running in the lab, and the user who in fact submitted the query, and also the information regarding the query text, state, and can also be shown. And you can subsequently customize the tables that you wanted viewed. So for this instance, I've had the added the queue time, and additionally, when you click on the overflow column, you can subsequently view the execution plan or open the query in the particular workspace. And last but not the least is the access control page. So this is used to manage all the infrastructure access and the data access policies, and security and access control within extra data is based on roles. And control at the infrastructure level allows permission to be granted on the engines, the catalogs, buckets, and databases. And roles includes admin, manager, user, writer, reader. And access to the data itself is managed through data control policies, and policies can be created to permit or deny the access to the particular schemas tables that we have created in the platform. And in this section, we will in fact be adding a new user, provide them with the necessary privileges over data and infrastructure, right? Using the command line interface, I have in fact created a non-administrator user. Now I will click on the different components and add users to this particular in this. So for this instance, I'm creating a user for this Presto. I'm adding user one was the one who I created using CLI, and for role, let me just assign him user. As you can see, apart from the admin access, I do have a user, and his role for this instance is user. Let me also do this for the iceberg bucket, and let me give access. Yes. Let me just try refreshing and see if the user is showing in this case. Yes. Infrastructure, iceberg data, add access. Yes. And user has been given the user access. So in a real world scenario, when a user is actually trying to get information, querying data from the table, they will need to be given at least a minimum of user access to the engine. In this case, Presto, and user access for the catalog, which in this case is Hive and catalog. They will be able to see the schema information associated with the table, and they need to be given reader access to the bucket within the data to be able to read the data from the object storage. So just to summarize, user needs user access to the engine, user access for catalog, and reader access for buckets associated. Let me also define the policies. Add policy, my cars, right? Policy status after creation. Yes, I want it to be active after creating it. Hive data, no, my table cars is under the iceberg catalog. Schema is my schema, and under my schema, I want to associate the table cars which I had uploaded offline. Search yes, columns yes. Next, add rules. Allow actions, they can select, no create, no to drop, alter, yes. User, select a user, and let me create it for the user one whom a non-administrator user had created through CLI. And let me just review this policy. My cars active from the iceberg table, allow select user, and let me just save this. And there you go, right? So congratulations, now you have viewed how the infrastructure pane works, how the data pane works, how you can run queries, how you can access the query history, and also set policies and role-based access for your user. So for the interest of this lab, you have seen Presto integrated into the watsonx.data interface. However, Presto includes a terminal-based interactive command line interface that allows you to run statements. And the Presto CLI is terminal-based and can be used to run queries. However, for this lab, we won't be taking you through that. However, the Presto CLI is pre-installed when you download or install the watsonx.data developer edition. So just wanted to say that all these queries that you're running on the platform can also be run as part of the Presto CLI. Apart from the command line interface, Presto in fact has its own web interface for monitoring and managing the queries that runs on Presto, and it's a very great place to get information about the running queries and the completed queries. So this includes the query state, the query text, the name of the user that ran the query, and the percentage complete if it's still running. Now let me click on the finished queries, and yes, the queries that I ran on watsonx.data using Presto is shown here. Let me click on a query ID that is in fact seems interesting. As you can see, this opens a new browser window with the query details page for that specific query, where I am being shared information of the execution, the completed time, the submission time, the prerequisite wait time, the time it's taken for the queue and planning. And you can scroll this particular page to familiarize yourself with the information that is available. And one thing of particular interest is something that is called as the live plan. And here is where you can see the query's execution plan and also the various steps that are involved in running their query. And the output is similar to what you see in the visual explain, that the output that we saw on watsonx.data, right? Now let me click on Presto's logo, and you're being redirected into the cluster overview page. And when you're done exploring this Presto console, you can close the browser and you can feel free to explore it even more. Also, a major appeal of the watsonx.data platform is that vast amounts of data can be stored in object storage at a relatively low cost compared to block storage. And this comes with fit for purpose query engines like Presto and Spark, accessing the enterprise data concurrently. And this allows, if you're a client, to offload your existing data from your data warehouse, where the performance requirements or the frequency with which you access this particular data doesn't justify the cost of having it in a warehouse. Additionally, with IBM DB2 and Neteza's tight integration with watsonx.data, you can access the data in object store directly, and queries can combine data in the warehouse with the data in the lakehouse. So this provides you as clients with a complete flexibility on where you store your enterprise data. So the developer edition that I'm using includes a local S3 compatible object store called MinIO. And rather than using something an external object store, this lab actually uses the local MinIO object store. However, the Watson VM Docker wasn't installed, so I would have to take you through screenshots rather than the entire platform. So once I pass the credentials, the object browser screen is open. There are two buckets, as you can see, that exist by default, the Hive bucket as well as the Iceberg bucket. And there are a number of objects within these buckets already. As you can see, 70 objects within the Hive bucket and 16 objects within the Iceberg. And these are pre-populated tables that we have created in the Iceberg bucket. So if I click on the Iceberg bucket, there are two folders listed in this case, one for each schema that has been created in the catalog associated with this bucket, which is the Iceberg bucket. And watsonx.data uses the schema name for the folder when you create it, right? Let me see the schemas. Yes. And when I clicked on new schema, the new schema folder has a subfolder called users. And when we created the users table in during the command line interface Presto's exercise, it created this subfolder with the same name as the table. When I subsequently click on users, there are two subfolders within this tables folder, and this data folder contains the Parquet file holding the actual data for the table, and the metadata folder contains a series of metadata files of varying data file formats, which is used by Iceberg. If you review the files within the data and the metadata folder, you will see a mix of Parquet and Avro files. And to return back to the folder hierarchy, you can use the navigation button that takes you to the parent of the folder that you're currently in. Yes. Now that is over, we are going to look at data ingest. So data ingestion is the process of importing and loading your data into the platform. There are multiple methods available. Either you can do it through the data manager page like we saw earlier, and the non-developer edition includes an access where you can includes an ingestion jobs tab, and you can also load the data for a table into an object storage bucket. However, in this section, we will see how you can use the MinIO console to upload a Parquet data file into the object data store, and we will also subsequently create a table on it using the SQL in Presto. I have a Parquet file called aircraft.parquet that is downloaded, and since this data file is not wrapped in the Iceberg format table, it needs to use a Hive catalog, and we will be using this Hive data catalog associated with a Hive bucket. In the Hive bucket panel, we will click on create a new path, and in the subsequent step, we will choose or create a new path, a pop-up window, enter my schema aircraft for the new folder path, and then click on the create button. So what this is going to do is create nested folders under the current bucket. The top level folder, my schema 2, should match the name of the schema that you're going to create later. And the next folder down, which is the aircraft, should match the name of the table that you're going to create later. Now you have the option to upload a file. You'll click on upload file. Within your system, you will select and upload the Parquet file that you had downloaded earlier. Perhaps I'll share that link. Now click the downloads uploads icon to close the downloads uploads panel. But as you can see, you have the option to hit refresh on the upper right. And if this is still showing empty, navigate up one level to the parent folder and then navigate back down to this folder. Now, if you click on refresh, file is listed as below. Now, that's it for understanding how you can ingest data through the min.io object console. So with Presto's federated query capability, enterprises can combine the data from their existing diverse sources with new data that they have as part of the watsonx.data platform, enabling them to rapidly unlock insights without the usual complexity and cost that is associated. And Presto supports a wide range of connectors, but the watsonx.data platform supports only a subset of them. This is because IBM wants to ensure quality, performance, and security of connectors before adding support. And in this section, we will look at how we can combine data from watsonx.data's object storage with data in IBM's own DB2. And they have already been installed in the same VM as the watsonx.data, and these are pre-populated with data. For this particular exercise, I had added another database component, that is IBM DB2. And once that details is done, when you create that database, as you know, an associated catalog is also created. However, when this catalog is created, it is not associated with a query engine. What we have to do is click on Manage Associations, select the engine that you want this to be associated, and restart the engine. Now let me go and see if this is reflected in the data manager page. So as you can see, the catalogs associated, if I click on the DB2 catalog, so when you click on the DB2 catalog, both schema and table information as shown as such, we are seeing the Go Sales DW schema. And now that we have copies of the Great Outdoors Company sales tables in object storage, that is Hive data, as well as the DB2 catalog, we will see how we can run a federated query that combines data from these two data sources. Yes. Now, this duplication isn't something that you will have in a real world scenario, because the benefit of being able to federate access to multiple sources of data is to avoid the concept of data duplication. However, this is being done in this case for the purposes of highlighting the Presto's federation capability. And the query that you see now is a sample query that could be used by the fictional business to determine which purchasing method is associated with the largest orders. So, in fact, if I had uploaded another database, and a SQL database, the query accesses 5 tables in this scenario, one of which is PostgreSQL, which is not done as part of this lab exercise, 2 in DB2, which we have seen, and 2 are in watsonx.data's object storage. And if you click on run on Presto, the result that you would get is shown on the screen currently. And you can further click on explain button, and you'll get a visual explain output of the query that looks a lot more interesting than the one shown earlier to the lab. So here are 2 other queries that you can try running as well, which combines data from not just one single source, but 3 data sources. This following query displays all the Canadian and Mexican employees along with the region and country. And this is the kind of query that a reporting tool might generate based on input from the user. Additionally, in many businesses, departments are very hierarchical in that a department falls under another department. Let's say HR falls under operations falls under something else, which in turn falls under another one. So this query displays the 2 parent departments for a given set of departments. As in the previous query, this is the kind of query that a reporting tool might generate. And as an optional step, you can try running the 2 queries not just from the watsonx.data platform, but from within the Presto CLI as well. But you should get the same results in the Presto command line interface as you did in the query workspace. So now we have seen the federated query capability of Presto and watsonx.data platform. And in addition to making it easy for us to access data across the enterprise, this also opens the door for significant cost savings. And as of today, many enterprises for their analytics or any transaction workloads maintain expensive data sources, right? Data warehouses, and whether they are on premises or in the cloud, they support mission critical workloads, yes, but there are often data in the workloads supporting less important or stringent workloads, and these could be offloaded to a lower cost solution. And this is what watsonx.data allows. And with watsonx.data, enterprises and businesses can offload data that doesn't necessarily have to be in warehouses like DB2 or any other DB. And with fit for purpose query engines like Presto and Spark, the cost can be significantly reduced by offloading those data. So for this example, we are going to move the Go sales dw.sls sales fact from the DB2 to watsonx.data's object storage, and it will be created as an iceberg table, and in a new schema that we call wx go sales div. And for the purpose of this brief exercise, I have in fact already created that schema. So all you have to do is create a new schema. Now, as I suggested, I'm going to create it under the iceberg data and write it as, yes, wx go sales dw. As you can see, yes, this is in fact reflecting in the iceberg data. And to create a new table with the same table definition as the original table, we can use the create table SQL statement in the query workspace. And I have that query already put in. Let me run it on Presto. And since the table already exists, I am in fact being thrown an error, but the result that will be shown at the bottom of the worksheet is this, showing the number of rows that have been inserted from the source table, which is DB2, into the new table under the iceberg catalog. Now let's move on from data offloading from a warehouse to the concept of rollback and time travel. So the iceberg open table format provides a number of benefits, including the ability to see a table as it existed at a point in the past. And this capability is useful in a number of different ways. For example, having the ability to query historical data for auditing purposes, and even if there is an application corruption that corrupts the table data in some way, you can imagine the value in being able to quickly reverse these particular changes by resetting the table to a known good state. And this is something known as snapshots that allows this time travel capability. So this represents a state of the table at some point in time. And as of end of 2023, the time travel queries are not supported, but in the Q1 of 2024, I think it is being supported. However, you can still roll back a table to an earlier point using time shots, and we will go through that process in this section. So I'm in the query workspace section, and I have the following SQL statement put into my SQL worksheet. With this particular SQL command, I should be able to see the output, that is the number of rows that exist in the table. Let me run it on Presto. Since the destination table, in this case iceberg data, my schema, output ID already exists, I'm being thrown an error. However, this is the particular output that you would derive, showing the number of rows in the table, that is 6,250. Now that this table has been created, we can navigate it by clicking on iceberg data, my schema, and clicking on airport ID. And this tab, in fact, lists the snapshots associated with the table identified by a particular snapshot ID. At this point, there is only one snapshot, and there are total of 6,250 records. On next steps, you can copy and paste this following SQL statement into the worksheet and run it on Presto 1. And subsequently replace this SQL already there and copy and paste this particular SQL worksheet and run it on Presto. And you should see that the row that you inserted in the previous step is shown here. Once again, do the same thing, replace the SQL statement and place this SQL statement. And now you should see a count of 6,251 rows. And as we did before, we will navigate to the iceberg data, my schema, and the airport ID table, and click on time travel. Note how there are now two snapshots compared to the one that was shown earlier. And if you do not see the second snapshot, then please refresh your browser. And the second snapshot obviously shows that there are 6,251 rows, with one row being added in the new version of the table. For our next step, we are going to roll the table back to the first snapshot, which represents the initial state of the table where we did not have the row that we entered. All you have to do is click on the overflow menu icon at the end of the row of the original snapshot, with the earlier committed timestamp. Click on confirm rollback pop-up window and click rollback. Now we will circle back to the query workspace and copy and paste the following SQL command into the worksheet and subsequently then run it on Presto. And as you can see, the row that you added earlier is now gone. Now we are going to enter this particular SQL command by replacing the SQL that's already there into the worksheet and run it on Presto. And there you have it. You should see a count of 6,250 rows, which matches the original count when we first created the table. And this table is now back at the state it was when it was first created. And huge congratulations on going through this entire video. You must have had quite experience in the following areas. We saw the watsonx.data web-based user interface, including the infrastructure management, the data manager, how to run SQL statements, how to manage user access. We also saw the Presto web interface, the Presto command line interface, how to ingest data through MinIO object store, how to ingest data into the watsonx.data platform, and creating schemas and tables, running federated queries that combine data from multiple sources, in this case DB2 and Hive data, offloading tables from DB2 into watsonx.data, which allows you to move the non-critical workloads from your warehouse architectures into your subsequent lakehouse architectures, which includes great cost savings. And finally, for our interest, we saw how to roll back a table to a previous point in time. I think as a result of going through this video, you should feel much more confident in your ability to adopt the watsonx.data architecture into your environment and realize great business value, not just in terms of cost, but in terms of simplifying how you manage your data and infrastructure components. Thank you for watching this video. Hope you found this to be fruitful.